A ball attached to a string of length L swings in a horizontal circle as shown above with a constant speed. The string makes an angle theta with the vertical, and T is the magnitude of the tension in the string. Express your answers to the following in terms of the given quantities and fundamental constants. A bit. On the figure below, draw and label vectors to represent all the forces acting on the ball when it is at the position shown in the diagram. The lengths of the vectors should be consistent with the relative magnitudes of the forces. B. Determine the mass of the ball. C. Determine the speed of the ball. D. Determine the frequency of revolution of the ball. E. Suppose that the string breaks as the ball swings in its circular path. Qualitatively describe the trajectory of the ball after the string breaks, but before it hits the ground. This numerical problem is based on uniform circular motion. Here, the ball rotates in a horizontal circle. And then we have to draw the forces acting on the ball here. Okay. I have redrawn the figure here because this is a screenshot. I can't draw on this. That is why I have drawn here. Here, the tension acts along the string upwards and then gravity acts downwards. Okay, this is the diagram for this one, force diagram on this. And then we have the components also. F tension X and F tension Y are the components, but he did not ask the components, only the forces, two forces acting on the ball. One is the tension and another one is the gravity. Both the forces directions I have shown, tension upwards and then gravity downwards. Next bit, determine the mass of the ball. So to determine the mass of the ball, we have to resolve the forces into components. See here, F tension is acting upwards and then with an angle theta. Am I right? This is the ball is hanging to the stand with an angle theta. Therefore, the tension is making an angle theta. Now I have to resolve the force into components. So X component is Ftx and Y component is Fty. From the geometry of the figure, we can find out Ftx and Fty. So what are Ftx and Fty? Fty is the Ft cos theta because this is the angle. So adjacent side, no, Fty means adjacent side to the angle. That is why this is Ft cos theta. And then x is opposite side. Therefore, Ftx is Ft sin theta. Okay, now we will write the force equation. Sigma Fi is equal to Fty minus Fg is equal to 0 because the ball is making a horizontal circle. Therefore, Fty is equal to Fg and we know Fg is equal to mg. Okay, and then Ft cos theta is equal to mg. This is Fty is equal to Ft cos theta now. Therefore, Ft cos theta is equal to mg or m is equal to Ft cos theta by g. This is the answer for the second bit. Next, determine the speed of the ball. To determine the speed of the ball, we will take the x component. What is the x component? X component is Ftx is equal to Ft sin theta, that is equal to Fc. Fc is the centripetal force. So, horizontal component of the tension contributes to the centripetal force. Okay. Therefore, here Ft is mg cos theta. From this equation, I can write Ft. Ft is equal to mg by cos theta. Am I right? Ft cos theta is equal to mg. Therefore, Ft is equal to mg by cos theta. Here, I will substitute that value. So, mg by cos theta times sin theta is equal to mv square over r. So, from this I can calculate V, no? So V is equal to, on simplification of this equation, I get V is equal to square root of GL sin theta tan theta. This is the equation for the answer for the C bit. Next, D bit. We have to find out the frequency. We know V is equal to 2 pi R by T and 1 by T is equal to F frequency because 1 by time period is equal to frequency. Therefore, V is equal to 2 pi R F. Or F is equal to V by 2 pi R. And we don't know the value of the, because numerical values are not known to us. Therefore, we have to convert everything into the known quantities. He is asking us to find out the values in the known quantities. So R is also not known to us. So we have to write R in terms of L. For that, what I do is I will take the geometry of the figure. Here, if you see the figure, here, this is L, this is R, this is a right angle triangle. Am I right? From the right angle triangle, sine theta is equal to R by L, R is equal to L sine theta. So this I use here, and then I will find out F. Therefore, R is equal to L sine theta, and then V I already found out here. Am I right? Square root of GL sine theta tan theta, V. Am I right? And then for R is equal to L sine theta. I substitute these values and then find out F is equal to 1 by 2 pi square root of G by L cos theta. This is the answer for the D bit. Now E bit. He is asking if suppose the string breaks as the ball swings in its circular path, qualitatively describe the trajectory of the ball after the string breaks, but before it hits the ground. So suppose this is the ball and then it's a trajectory. If the string breaks, what happens from here? It comes down. Am I right? So how it will be, suppose this is the maximum position. From here, it falls down. When it is falling like this, it is like this. Am I right? So it falls down. 1 second. It falls down. How it falls, this is a projectile motion. The object is under the free fall. No other force is acting because the moment the string cuts, breaks, no other force is acting on it except gravity. Therefore, the ball is under the free fall. It takes the circular parabolic path and then reaches the ground. This is the parabolic path. Okay, that's it. That is the answer for this question. Hope this helps. Thank you. Bye bye.